Hey everyone, and welcome to another deep dive. Today we're tackling something really fascinating. It's intelligence and consciousness. Get ready to explore some pretty mind-blowing research. We'll be diving deep into how our brains work, how we think and feel, and what makes us human.
Yeah, it really is amazing. Just think about it. The human brain, it's so complex, yet it's behind everything we do, feel, think, and there's still so much we don't know.
Okay, so let's start with intelligence. I think we can all relate to that. So when you hear that word, what pops into your head? Do you think of like a classic genius? Someone like Sherlock Holmes, solving crazy mysteries using pure logic?
Well, it's funny you mentioned Sherlock Holmes because he kind of embodies this limited view of intelligence, the one focusing on logic and problem solving. But intelligence is way more than that. It's not just about being good at math or acing an IQ test. There are actually many different types of intelligence, each with its own strengths and ways of processing information.
So you're saying it's not a one-size-fits-all thing, like there are the multiple intelligences. I've heard that before. Can you break that down for me?
Absolutely. One of the leading theories, the theory of multiple intelligences, suggests there are at least 8 distinct types. And these go beyond what traditional intelligence tests measure. They include things like linguistic intelligence, that's about language and communication. Then there's spatial intelligence, so that's your visual thinking and spatial awareness. And of course, musical intelligence. We can't forget about that.
So many different ways to be smart. It's pretty cool. Like a dancer, they might have high bodily kinesthetic intelligence. And someone who's amazing at connecting with people, that could be interpersonal intelligence. We all have our own unique blend of strength.
Precisely. And here's where it gets really interesting. Each of these intelligences is linked to specific areas in the brain. Research shows that damage to certain regions can actually hurt those abilities. Like there's this condition called amusia. People with amusia lose their musical abilities because of damage to a particular part of the brain.
Wow, that's incredible and a little scary. Our brains are so intricately wired for these different abilities. It makes you think about savants, those people with these extraordinary talents in some areas, but then they face challenges in other areas.
Savants are absolutely fascinating. They have these incredible mental capacities in specific domains like math or music or memory that just blow us away. You might remember the movie Rain Man. It portrayed a savant with extraordinary math and memory skills. These cases really challenge how we understand intelligence and how the brain works. It makes you wonder, do savants have access to something we all have but can't tap into, or do their brains just function completely differently? It's a question that continues to puzzle scientists.
Yeah, that adds to the mystery of the human brain. Okay, let's switch gears and talk about another big one. Consciousness. We use the word all the time, but what does it even mean? What's the difference between a conscious being and, say, a plant or a computer?
Consciousness is like this layered tapestry of awareness, and it's not a simple on or off switch. Even simple organisms like bacteria show some basic awareness reacting to their environment. But as we move up the complexity ladder, we see things like self-awareness and metacognition, those emerge in humans. And internal models play a huge role in this.
Internal models. That sounds interesting. Can you explain a little more about how those work? What's their purpose?
Think of them as mental maps. These representations of the world help us interpret experiences, anticipate what's next, and guide our actions. It's like our brains are constantly running simulations based on what we sense and experience.
So our brains are like tiny movie directors building their own virtual reality based on our perceptions. That's a cool way to think about it.
Exactly. And language plays a big role in building these models. By giving names to things and categorizing them, we create a framework for understanding. It's like organizing all that sensory chaos into meaningful patterns.
So that we can think about our own thinking, right? That's metacognition, being able to reflect on your own thoughts and mental processes. It's kind of mind-blowing when you really think about it.
You got it. Metacognition is like a signature of human consciousness. It's tightly connected to language and allows us to not just think, but analyze how we think. That opens up possibilities for things like abstract reasoning and self-awareness.
We often hear about emotions being separate from intelligence, almost like they're at odds.
Yeah.
But how do emotions actually factor into our mental processes, especially when making decisions?
You're hitting on something really important. Emotions, they aren't just separate from our rational thoughts, they're intertwined. And a key player in this is the limbic system, the brain region that processes emotions.
So the limbic system, what does it do exactly?
It's responsible for processing emotions and giving us those gut feelings, the ones that can sway our decisions. It works closely with the neocortex, which is the part of the brain responsible for higher level thinking.
So those gut feelings, they're not just random whims, they're actually connected to how our brains are processing information. That's fascinating.
Absolutely. There's this theory called the somatic marker hypothesis. It suggests that our emotional responses, those gut feelings, actually help us make rational choices. They tag certain options with positive or negative feelings based on past experiences. Like
Yeah.
when you have a strong feeling about something, even if you can't explain it logically.
Oh, I've definitely had those moments where my intuition just steered me in the right direction. It's like our emotions are giving us hints, even when we don't realize it.
Precisely. Our emotions processed by the limbic system are a big part of decision making, working hand in hand with our rational minds.
This is so cool. It's like we're peeling back layers of an onion, and each new discovery shows how complex it all is. Have you ever heard of the triune brain model?
Yes, the triune brain model is a simplified way to think about brain evolution. It says our brains have three layers, each representing a different stage in our evolutionary history.
Okay, break it down for me. What are these three layers?
So the first is the reptilian brain. It's the oldest part. Handles the basics like breathing heart rate and our fight or flight response. Then there's the paleomammalian brain, also known as the limbic system, which we just talked about. This one governs emotions, memories, and social behaviors. And finally, the neomammalian brain. That's the neocortex where language, abstract thought, and planning happen.
Wow, so it's like we're carrying around these ancient parts of our brains, each layer adding new dimensions to our capabilities. Pretty amazing, right?
It is remarkable, and while the triune brain model has been challenged by newer research, it's still a useful way to visualize how our brains developed over time.
It makes you wonder, are there different levels or types of consciousness? We tend to talk about it like an on-off switch, but is it more nuanced than that?
You're absolutely right. Consciousness isn't just black and white. It's on a spectrum ranging from being super aware to states like sleep coma or even altered states through meditation or certain substances.
So there are shades of gray to consciousness. What determines where someone falls on that spectrum?
Lots of things. Brain activity, sensory input, emotional states, and even our own choices play a role. Have you ever noticed how your mood can affect your decisions?
Oh yeah, all the time. When I'm stressed, I tend to make impulsive choices.
Exactly. And we also have this amazing ability to consciously override impulses. Some call it veto power. It's important for free will and moral responsibility. We can resist temptation or go against our initial urges, like when you choose to do something difficult but important even though you don't feel like it.
Like choosing a healthy salad when all you want is pizza. Sometimes willpower wins. But how do scientists even study something as subjective as consciousness?
It's definitely tricky. One way is to observe behavior and try to figure out what's happening with awareness. For example, studying people in a coma or with locked-in syndrome where they're conscious but can't move or communicate can teach us a lot. Another approach is to directly measure brain activity using things like EEG or fMRI. They show us which brain regions are active when someone's consciously aware of something.
Wow. It's like we're peeking into the brain's control room and seeing the circuits light up when we have a thought or experience. Technology is incredible.
It really is. And sometimes those insights lead to ethical questions. Like with anesthesia during surgery, we're learning that being totally unconscious might not always be necessary. That raises new questions about awareness and patient experience during those procedures.
That sounds like a whole other deep dive just waiting to happen. But for now, I'm curious about the other side of things. Unconscious processing. How much of our brain activity happens without us knowing?
It might surprise you to know that most of our brain's work happens unconsciously. It's always
Wow.
processing tons of information, filtering what's important and directing our attention, all without us realizing it.
So our unconscious mind is this super efficient machine working in the background, and our conscious mind takes the credit.
That's a great way to put it, and there's so many cool examples of this. Have you ever heard of blind sight?
Blind sight. That sounds like a contradiction. What is that?
It's when someone has damage to their visual cortex, the part of the brain that processes sight. They say they can't see, but they can still react to visual stimuli in some ways.
Wait, so they can't see, but their brain is still processing visual information on some level. How is that possible?
It's wild, right? It shows that we can perceive things without even knowing it. Another example is priming. Being exposed to something unconsciously influences our responses later, even if we don't remember seeing it.
Okay, give me an example. I'm intrigued.
Imagine you see a billboard with the word bank. Later, you're asked to complete a word that starts with back. You're more likely to say bank because of that billboard, even if you didn't consciously notice it.
That's amazing. Makes you wonder how much control we really have when so much is happening below the surface.
Exactly. And then there's the cocktail party effect. You're in a noisy room, but you can still hear your name even if you weren't consciously listening for it.
Oh yeah, I've definitely experienced that.
Yeah.
Our brains are like these amazing filters, always looking for important information.
They are. And there's even a condition called neglect. People with damage to a specific brain area can't attend to one side of their visual field, so they might only eat from half their plate or shave one side of their face, even though their vision is fine.
Wow, it's fascinating and a little freaky to think about all these unconscious processes affecting us. I've been surprised by my own unconscious biases before. It's a good reminder that what we consciously experience is just the tip of the iceberg.
Absolutely. There's so much more to us than we realize.
Well, this deep dive has given me a lot to think about. It seems like with intelligence and consciousness, every answer just leads to more questions.
That's what makes studying the brain so captivating. It's a never-ending journey of discovery, and each new insight shows us how much we still have to learn.
And we'll continue this incredible exploration in just a moment, so stay tuned.
And we're back! Still diving deep into this amazing world of the brain. You know, all these things we've been talking about, conscious decisions, those hidden biases, it all comes from this incredible structure, the brain itself.
Yeah, we've explored the ideas, but what about the actual physical part that makes it all happen? Let's talk brain anatomy. It's all connected, right?
You bet it is. When we talk about intelligent behavior in mammals, especially humans, the neocortex is key. Think of it as the brain's CEO. It's at the top of the neural hierarchy.
So the neocortex, it's like the boss making all the big calls.
Pretty much. It's divided into modules, each handling something specific like language or visions. And get this, those modules are divided into submodules and so on, all the way down to neurons and synapses.
Whoa, that's seriously organized. Like a company with departments, teams, and each person with their own job.
I like that analogy, but the brain isn't just top down. It works in parallel, too.
Yeah.
Different parts can process things at the same time. That's how we multitask and react quickly.
So it's like different departments working on different projects all at once. But somehow it all flows together. Our brains are so efficient.
Exactly. And here's another mind-blowing thing. Even with all this action, only a tiny bit reaches our conscious mind. Most of it happens behind the scenes.
It's kind of crazy to think about all that's going on in our brains every second without us having to think about it. We really take it for granted.
For sure. And to get how the neocortex manages it all, we have to look at how it interacts with other parts, like the thalamus and the hippocampus. These guys have been around for millions of years. They help with relaying senses, forming memories, and even regulating those emotions we talked about.
So it's like the neocortex, our CEO, gets reports and info from other departments to make decisions and guide our actions.
Precisely. And don't forget those lower brain structures. They're even in animals that came before humans, even those without a developed neocortex.
So creatures like reptiles and amphibians, they might not think like us, but they still share some of the basic brain structures we need to survive.
You got it. It really highlights the continuity of evolution. Our brains built upon these ancient foundations to become the complex organs they are today.
It's humbling. We may be at the top when it comes to thinking, but we still carry around pieces of our ancient past
Right.
in our brains.
Absolutely. It's a reminder of the incredible journey that made our minds what they are today.
This deep dive has really changed how I understand intelligence and consciousness. We've just scratched the surface of these mysteries.
Oh, for sure. There's still so much we don't know about the brain. But with every discovery, we learn even more about how amazing it is. And who knows what the future holds.
Well said. Let's take a quick break, and we'll be right back to wrap things up. And we're back, ready to finish our exploration of intelligence and consciousness. It's been quite a journey, but there's one more big piece to the puzzle we got to talk about.
You're talking about language?
Right.
It's a huge part of what makes us human and shapes how we think, see the world, and even understand ourselves.
Exactly. We touched on it earlier, but let's go deeper. How does language actually affect our thoughts, our perceptions, and our sense of self?
Language. It's an incredible tool. We use it to communicate ideas, share stories, and build these complex social structures. But it's more than that. It shapes how we understand the world around us. By naming and categorizing, we create this mental framework, a way to organize all the sensory input we get.
The language provides the labels and the filing system for our brains.
That's a great analogy. And these labels and categories, they're not fixed, they're always changing. We learn new things, experience new cultures, and our understanding of the world grows.
It makes me think about how different languages could lead to different ways of thinking. You know, like that example with the Hopi language. They don't have separate words for past, present, and future. Do you think that means they experience time differently?
That's a fascinating question. It's a big debate among linguists and anthropologists. It's hard to say for sure if language determines thought or just reflects it, but there's some evidence that suggests the structure of our language can affect how we see and categorize things.
It's crazy to think that something as seemingly basic as language could actually shape our reality.
Yeah, it highlights the importance of being aware of the limits and biases our own language might put on our thinking. We should always be open to different perspectives and question what we think we know.
Speaking of different perspectives, what about artificial intelligence? Could AI ever actually become conscious? It's a huge topic in sci-fi, but is it really possible?
That's a question with some deep philosophical and ethical implications. AI has made incredible progress in recent years. It can do things we never thought machines could do. But there's still this big difference between AI as we know it and human consciousness.
What's the missing piece? Is it just a matter of computing power, or is there something more fundamental that separates us from even the most advanced AI?
That's the big question, isn't it? Some believe it's only a matter of time before we create machines as complex as the human brain. Others argue that human consciousness is unique. It can't be recreated with algorithms and computer chips.
Like there's this special something, a subjective experience that goes beyond coding.
Exactly. And even if we made a machine that could pass the Turing test, convincingly imitate a human conversation, would that really mean it's conscious? Or would it just be a really good imitation?
It's a question we'll probably be debating for a long time as AI gets more advanced and the line between human and machine blurs even more.
And it's important to have that debate. As we learn more about intelligence and consciousness, we have to think about the ethical side of our progress. What does it mean to create a machine that can think and feel? What responsibility do we have to those creations?
Those are big questions we need to face as a society, and there are no easy answers. But this journey of exploring our own minds and the potential of AI, it's both exciting and a little scary.
Absolutely. It shows how important it is to approach these questions with curiosity, humility, and respect for how complex the human mind really is.
Well said. This deep dive has been incredible. We've traveled from our ancient origins to the cutting edge of AI, all to understand the mysteries of intelligence and consciousness. We may not have all the answers, but I think we have a deeper appreciation for just how amazing the human mind is.
I couldn't agree more. It's a journey worth taking, a quest for knowledge that will keep us fascinated for generations to come.
To everyone listening out there, keep exploring. Think about your own experiences with consciousness. Think about the mysteries of the brain, and never lose that curiosity. Understanding our own minds, that's the greatest adventure of all.
It really is. And who knows what amazing things we'll discover next. Until next time, keep diving deep.